Thank you. All right. So the talk this morning is not really a training, but I want to basically just share and deal with this whole issue of capacity and capability development, because I think it is within the reach of all nations, all peoples, and I believe that it is also the right of every people to have access to technology that can and will benefit in our area of discussion, in the whole area of veterinary diagnostics and the use of molecular technology. Now, let me just briefly, very quickly, give a brief introduction. My name is Robin Liu. I graduated from with a BSc in microbiology back in 1990. So I'm not young. I'm already close to 60, and I did my master's in 1995. I guess perhaps many of you maybe were not even born during those years. I've founded 3 companies, and all of them are biotech related. And currently, I'm involved in the whole area of technology evaluation and assessment. In other words, a lot of my work is to look at technology and how we can actually deploy them in a very practical way, in a cost-effective manner, into different localities and countries. So my current role is as the Business Development Director for Lab-Ind Resources. Let me just move on to the topic for today. Maybe just as Dr. Adebayo has mentioned, this is the last session in our series of 3 talks. We began much earlier, where we focus on the whole area of molecular diagnostics. And we looked at, in the first session, the different platform technologies from microbiological to immunoassay, for example, ELISA or serological testing method, which perhaps many of our listeners today are very familiar. If you are a vet, then you will also know the whole area of the use of antibody biomarkers, all right? Titers as an indicator, for example, for infection and so on and so forth. And we also look at the whole area of molecular diagnostics and why molecular diagnostics has a very critical part in this whole plethora of diagnostics and screening method. About 2 weeks ago, on November 23rd, my colleague spoke about the practical application and deployment of molecular diagnostics platform into aquaculture and poultry. So the last session today, really, I'm going to talk about this whole area of capacity and capability building. And I hope that at the end of the talk, you all will give you that inspiration to reimagine how this can also be deployed into your current locality in a very practical way. All right. So let me just move on. So as Dr. Adebayo has mentioned, we are talking about concepts this year, and hopefully from next year, if we could, we will put up, for example, demo systems, all right, to be deployed and to demonstrate that it works even within Nigeria and in your context. All right, so this is what I'm going to talk about: capacity and capability development for molecular testing. Now, let us look at the definition of, firstly, this word capacity. Basically, from the simple layman's understanding in terms of English, when we talk about capacity, is the ability to receive something, to hold and to absorb. In other words, receive something, retain it, all right? Retain it, and it becomes part of you in that sense. So that talks a little bit about what the layperson will understand about this word capacity. Now, I want to talk about capacity development, and this is actually a very technical term as defined by the Organization for Economic Cooperation and Development, OECD, the Development Assistance Committee, DAC, 2006. They define capacity development as the process whereby people, organizations, society as a whole unleash, strengthen, create, adapt, and maintain capacity over time. Now, what does it basically mean? It basically means the ability of people and organization and society as a whole to manage their affairs successfully. And therefore, in our context, when we talk about capacity development in terms of molecular testing, what we are actually saying is that, you know, to unleash, to strengthen, to create, and to also the ability to adapt and to deploy technology over time. In other words, you receive, you strengthen your capability and knowledge, and therefore to redeploy that in a practical manner. All right, so this is basically the understanding of capacity development. And very quickly, I just want to also look at the whole area of, sorry, sorry. Just give me a minute. Let me. The second definition will be capability. And in simple English, its capability refers to skills, knowledge required for a particular task or competency. All right. So capacity and capability development. And capability development basically also refers to creating new capability and enhancing existing one. In other words, it is something that has not been deployed or done before this. Now we are able to attempt it and to successfully do it and to also maintain it. That is capability and capacity, and to enhance the existing skills. Now, the whole concept of capacity and capability development is actually very complex because it involves multiple stakeholders, and as was defined, it will involve organizations, and that will involve government, involves policy, involves vision, involves infrastructure, whether it is legal as well as physical infrastructure and systems in place. It also involves people, the whole area of training, mentorship, leadership development, skill, and competency. So it's a very complex topic, but I just want to make it as simple as possible at our level for us to reimagine what are some of the drivers to capacity and capability building. And I want to suggest three for our for my sharing as well as discussion this afternoon. Number one, technology levels the playing field. Number two, the whole area of democratization of life science, for example, okay? Democratization of life science. The third area is increased accessibility. To me, I think these are some of the drivers, apart from the more complex issue about policies and vision and government leadership and so on and so forth. I think at our level, I just want to highlight these three areas. Now, let me just begin by looking at technology levels the playing field. I want to just look at this whole timeline about computer, the development of computers and systems. I think in the past, if you look at this picture that I'm showing you, computers in the past are really huge, bulky, you know, and expensive, and yet very slow. Okay, the capability to do computational tasks is actually, compared to today, is considered as very minuscule. All right. Now, with the development of vacuum tube, okay, from vacuum tube we move to transistor, solid state transistor, meaning that circuitry and electronics begin to become part of our normal life as technology develops. Then we move on and we can see basically desktop computer. All right. And today, as technology continues to evolve, laptop becomes, for example, something very common in many parts of the world in general. And from laptop, from microchips, today we move on to mobile phone. All right. And therefore, even as we look at the progressive or the evolutionary pathway of computers, you realize that, you know, it is moving from one stage to another, and as it begins to develop and advance, things becomes smaller. Number one, miniaturization. Number two, cost. The cost becomes lower and lower and lower. And even today, I think mobile phone is something that is accessible in almost anywhere. It's almost ubiquitous in all countries. So I think this is, as we look at this whole development of technology, levels the playing field. In other words, technology is able to help us to level up in our lives. And in the same way, I think for us in the sciences, in veterinary science and so on and so forth, let me just show you, for example, this picture. This is actually a PCR machine, all right, that is used in laboratories, in sophisticated laboratories, in advanced laboratories, and it is big. It is also expensive. Now, because of technological development, today, you know, from this, we have gone to this small system, low-cost based, PCR-based system, and handphone is as powerful as any computers this day, and it can do a lot of. It has a lot of function apart from just as a communication tool. There are apps that allows the handphone to actually control small devices like this, low-cost devices, and yet, you know, is able to do molecular amplification, for example. I show you another picture. This is, for example, electrophoresis and gel imaging system. Huge, big. But today, again, everything is miniaturized. And you can also see the use of handphones again. All right. So what I'm basically trying to say is that as we look at technology development, that technology levels the playing field. What was done or only confined previously to advanced laboratory in terms of molecular diagnostics, today we can actually have access and apply it even wherever we are. This is, for example, this is one example. In the past, you need to have good laboratory infrastructure to run, for example, molecular testing. And today, this is a live example of a low-cost, field-based system, molecular system that is being deployed even in Zambia, in Colombo, Lusaka, and Chindu. All right, systems that are small, robust, low cost can now be used in the whole area of pathogen screening and testing, molecular method. And this is another example. I think all of us are aware of the Ebola outbreak back in Sierra Leone a couple of years ago. And this is Professor Ian Goodfellow from Cambridge University, and he was part of the international team helping to sequence the Ebola virus in the field. And this is what he said, you know, our traditional, very expensive, for example, real-time machine that costs about 30,000 pounds were unable to reach 22 degrees. But the simple, robust, low-cost system did a fantastic job. All right. And in fact, this simple, low-cost system are also being used, not just in the whole area of helping them to quickly amplify the target to sequence, but it is also used as a training tool, all right, to train laboratory technicians. And therefore, you can actually see how, you know, technology levels the playing field. All right. So this is the first driver, all right, in helping us to build capacity and capability. The second driver is, as I mentioned just now, is the whole area of democratizing life science. I think in many countries, we talk about STEM, science, technology, engineering, and mathematics. All right. And in Malaysia, for example, one of the things that we have been doing, it's to try to democratize life science. In other words, the study and the knowledge of life science and the experience of doing life science should not be confined just to university, to the ivory towers, confined to few people. But we want to democratize that, to expose the society and population to the wonders of technology, wonders of, for example, molecular biology in bringing benefit even to society, in helping us enriching our lives. So let me just share this second part of what I believe are drivers in capacity and capability building. These are all stories and life examples. What you're actually seeing here is really, we have been doing as part of our capacity building, exposing even secondary school students to the wonders of molecular biology, all right? And we are running, for example, DNA science workshop. In other words, we bring real life science into the classroom so that the students and the teachers, what you are actually seeing are teachers, science teachers, who are actually teaching about the subject, but they have never experienced hands-on, all right? Same like the students as well. So what we are doing is to build a capacity to generate a kind of interest and excitement to inspire. We basically we organize quite a fair bit of a DNA science workshop for schools, for teachers, science teachers in particular. And these are pictures where you can actually see the students. They are excited, you know, because this is first time for many of them to at least have a chance to to be involved, to run the test themselves. And you can actually see this particular student loading the product into gel electrophoresis. All right, same here. And this, for example, the low-cost thermal cyclers. And these are the different lectures that we do, workshops that we run. This is, again, another picture of a very simple setup. And in principle, this is already a molecular setup where you can actually run your molecular test. All right, simple. And we actually do it within the confine of classroom as an introduction. And I guess the most interesting thing, for example, is, as I've said, the use of technology, handphone. All right, and this is a result that we capture using handphone. And for those of you who run molecular work, you know that this is the electrophoresis, gel electrophoresis, and we could capture this using handphone. All right, and also interpret the results. And what you actually see here, for example, is a workshop that teaches about genetically modified organism and how we could actually use molecular method to detect whether the plant source or the plant ingredient is GMO or non-GMO, for example. All right, so things like this, as the students are being taught, involved, and engaged, we want to inspire them. We want to create that kind of excitement and to build the kind of capacity in terms of the number of people who will be interested in STEM. I think the third driver is increased accessibility. And I'm going to share basically just a story in Myanmar, some of the work that we have been doing amongst at the University of Yangon, in particular the Department of Aquaculture. All right, I think in many universities, sometimes or most of the time, the tendency is they will always go for very expensive systems, top sophisticated and expensive system. The only drawback is that sometimes you only have one machine and nobody actually gets a chance to work with the machine. And there's basically restriction and limitation to accessibility. Now, what we have done in Myanmar at the University of Yangon, and this is a project that we did with the German International Development Corporation, GIZ, from Germany, is really to change the mindset whereby instead of going for very expensive equipment and single piece equipment, it is better to invest into low-cost systems that are more distributed. And what we have done, as you can actually see in this picture, is to set up very low-cost thermal cycler system. And basically this is, for example, a PCR machine, all right, that we can just connect to any laptop. We can also connect to handphone, and from there we can program and run. And we do training, firstly for their academic staff, all right, because they need to be trained. They know or they study in the textbook, but they never had access to real hands-on experience, all right? And also for their postgraduate students. So with this kind of a low-cost, more distributed kind of a system, the university is able to build up more manpower by giving them opportunity and access to work on their skills, all right? And what you actually see here, again, as I've said, is the same thing, a gel electrophoresis, and we use handphone to capture. And the training, for example, in the department of the aquaculture department, one area would be disease screening, all right, or pathogen screening. Not so much of diagnostic, but pathogen screening of the broodstock as well as the progeny. And you can actually see that, you know, they could actually get results and do some interpretation as well as to take further decisions on some of their samples. This is again the same picture. Now more people can be involved, can have the opportunity to have hands-on experience, and even from their field samples, immediately we could quickly diagnose and come to a conclusion that, you know, some in this particular case, some of the post larvae or the fingerlings that are being stocked are actually infected by a particular virus. In this case, it's called a Macrobacterium nodavirus, Macrobacterium rosenbergi nodavirus. All right. Now, I'm sharing this example, this story is because what we are trying to say and to share with you all is that it is possible that they are low-cost based systems that can actually be deployed, all right, and into the field. Now, this is also another example, and this is actually in Malaysia. Again, we were working with this customer, and they basically have produced broodstock, and they also produce the post larvae that they supply to the farms. So they are actually working on what we call all male Macrobacterium culture. All right, and this is actually a freshwater prawns. All right, and same thing, we are using a molecular setup, low cost base, to help them to check and to ensure that the animals that they are working with are free from diseases. All right. Now, I will bring my sharing to a conclusion, and let me just summarize what I believe are the three drivers that will allow us to build capacity and capability in terms of to develop that in terms of molecular testing. All right. Number one, technology levels the playing field. We need to know what is available, all right? And once we know what is available, what technology is accessible, we can actually deploy that as part of that whole process of building capacity and capability. I think number two, the whole area of democratization of life science. We need to build the pipeline. We need to bring more exposure and to create interest, even amongst, for example, at least here in Malaysia, interest of students, all right? So that as they experience the excitement of running and seeing results for themselves using molecular method, that it will inspire them to pursue a career in STEM, for example. Then the third area, and this the driver for capability and capacity and capability development will be increased accessibility. All right, that we need to move away, you know, from and look at more distributed kind of a system where it is low cost. And that will allow increased accessibility to build knowledge, skills, as well as competency. All right. One of the things, for example, in some industry, for example, in the aquaculture industry or even in the veterinary industry, what we actually need will be more competent, for example, laboratory technologies who can actually work with the necessary skills, for example, for screening or for diagnostics. All right. And I think finally, the whole area of what we call low-cost system is already available, that we can actually deploy systems that are affordable, practical, and the technology can be taken up with less barrier, with less barrier. So in the whole area of capacity and capability building, I just want to encourage, and I hope that some of this story would actually inspire you all to see that to deploy, for example, molecular testing using low-cost based system is doable, and actually it is not expensive. But you need to have that necessary know-how to know how to deploy them, to know how to put them together, to also know how to have a training, all right, to build up the capacity as well as the competency. Now, this picture I'm showing you is what I call a low-cost based system, and systems like this, very simple, low cost, all right? You can actually do this, and it has been proven. You can use it for human pathogen testing, molecular diagnostics. We can also use the same platform for poultry pathogen, all right? For livestock, African swine fever, for example, or foot and mouth disease. Fish pathogen for environmental analysis, water, food compliance. In Malaysia, for example, when we talk about food compliance, it's the whole area of, sometimes we can also use method to do adulteration testing or the presence of non-permitted species. And also food pathogen. All right, I'm going to end, and my last slide basically is just to share with you in terms of capacity and capability building, low-cost based systems such as this. This is an example where we have actually developed for the aquaculture industry, and systems like this can now be deployed, to test a wide range of pathogens that are critical to the industry that concern. All right. So this is what I want to share in this whole area of capacity and capability building or development. So if there are any questions, please feel free to contact Dr. Adebayo, and we'll be more than happy to follow up with any of your inquiries going forward. All right. So thank you very much for your attention. Over to you, Dr. Adebayo.
Very thank you, Robin. Thank you so much for this insightful, interesting, and inspiring presentation. To be very candid, when we set out to commence on this training, our goal was to ensure that, say, in the next 5 years, we can have routine molecular diagnosis done in all the veterinary labs in the country. And I think from what you have said now, that if the secondary school students could have access to training, could have access to applying these molecular diagnostic techniques, I don't see any reason why we cannot make a commercial sense out of these wonderful opportunities that we have ahead, just at our fingertip. And in short, I still want to thank you once again for some of those pictures, because it actually kind of gave an impression of the possibility, immense possibility, an opportunity that we can actually apply these tools and the techniques in the veterinary. So it is actually wonderful to know that this opportunity is available and accessible, not just available, but also accessible. So we have the students that are doing their research can easily do some of these their studies in a molecular way to be more definite and to give something that is more robust to the world of science. You know, when it comes to pathogen, we have that a lot as it is assumed in Africa, and Nigeria being the biggest country in Africa is actually, it should be a source of inspiration to other African countries when it comes to knowledge sharing, knowledge communication, knowledge impartation. We should be, and that's one of the reasons why we should be able to come out with something more contemporary and not something obsolete when it comes to scientific research. And more than scientific research, and when it comes to also the common routine molecular, routine diagnosis, we should not just limit our diagnosis to just serology or the microbiology or just all of these analyses that are kind of limited. You can tell that this is the pathogen that you are dealing with, but unfortunately, what about the ones that are actually resistant to some antimicrobial that you are using in the country? How are you going to get to know that if you are not doing something molecular and can give you answers to so many questions that we have, or even look at the myriad of questions in the mind of farmers, livestock farmer, poultry farmer, aquaculture farmers. They've been doing things in that they have been working well for them, and all of a sudden that stopped working well for them, and they ask question, why is this not working anymore? Because we've been using this one routinely and it's been working for us. And they take the sample to the laboratory for an answer, but unfortunately, because the laboratory is also limited, there is a limit to the answer that the laboratory can provide. And some of these things should not stop us from giving help as professionals to the farmers that are actually desirous to have an expansion in their farming business. And if we want to really help them in this fast-paced changing world, then we need to be more contemporary and be deliberate about being more contemporary. And that is one of the reasons why I said it's really very inspiring, your presentation today, that this is not just a mirage, but a serious possibility with this presenting opportunity. And I think it's a good thing to know to make good use of that. So if you have questions on, in your mind, I think the question and answer section is open. You can ask questions. You can drop your question there. I know there is a question already, which we're going to be taking. But if you still have some that you have in mind, you can drop it there so that we can actually attend to the question. And if you want to speak out, you have a question, you don't want to type, you prefer to talk, you can press on the raise hand button so that you'll be given an opportunity to ask your questions directly. And if you're not comfortable with either of the two, you can also drop your question with in the chat box so that we can take it from there and we can attend to it. So I think the first question that we have here is, can you please give a price estimate and example of a low-cost and portable molecular diagnostic setup? Mr. Robin, back to you.
Okay, thanks. I think this is a question from probably Mr. Muhammad Umar. Yeah.
Yeah.
Now, let me give you an indication because I think different countries, because of the importation tax or the government regulation, but it will be a fraction. For example, in our own experience, I can just roughly give you an indication of, for example, even for less than 5,000 US, for example, in some places, we can actually put up a functional system, all right, that can run most of the molecular testing. Now, the key really here is about knowledge. I always tell people, for example, if you want to drive from point A to point B, all right, it doesn't really matter what car you use. Although you need to have a good car. Let's say, it doesn't, whether it's a Mercedes or a normal Japanese car, for example, a Toyota. What is more important is you must know how to drive. And when you know how to drive, you can move from point A to point B, irrespective of whether it's a Mercedes, a German car, a Japanese car, whatever car. All right. I think the point we are trying to highlight to you all in the whole area of capacity and capability, technology has made it possible that some of what I've shown you, even low cost based system, a couple of thousand ringgit, a couple of $1,000 US will not be more than, I think, 5,000, less than that. And it also depends on your type of application. For example, if you are working with non-zoonotic, meaning that these are pathogens that do not jump across species to infect humans, then the biosecurity setup will be less stringent compared to, for example, if you are dealing with COVID-19, SARS-CoV-2, then part of your whole setup, it can still be very low cost if you know how to do it, and we know how to do it, and yet maintain the kind of that still provides the kind of protection to the user and to contain the potential pathogen from escaping. All right. So what is the cost? I think compared to, for example, the example I told you, Dr. Ian Goodfield was telling us, real-time PCR machine, 30,000 pounds, compared to that system, which probably costs about less than $1,000 US, kind of a situation where things can still run and work. All right. So I think, firstly, technology, you need to know what is available. So low cost based system is one, and that can easily be deployed. And number two, to sustain that, that's where you need training, that knowledge, that understanding. And usually this would be augmented or enhanced when you actually practice this. Like some people say, I hear, I forget, I watch, I remember, I do, I understand, kind of situation where when we give them access, I think that would actually inspire and help people to learn better. Yeah. I hope that answers your question, Mr. Umar.
Yeah. Yeah, it's a great answer. If you ask me, great answer. So it's not about the cost. Yeah, the cost is important because from all the indication, if you have to set up, you have to buy. But more than just the cost, you really need to know what you can achieve with what you want to buy.
Yes.
There is a way in which value makes money insignificant. If you understand the value of what you are going for, how much it costs will not really matter. But if you don't understand the value of what you're going for, then you may have to start doing some unnecessary calculation on something that is something that is actually very affordable and at the same time accessible for use. So value should be the priority, and then we can start looking for, okay, how do I get it down and how much will it cost? And like I mentioned, and you heard Robin also mention the same, that we are planning on going to a kind of more direct capacity building this coming year. We are actually going to be sending a mail to that effect. But many people are very interested in that immediate, the direct practical section training. You can also send email address to Josiah. The email address is actually had been earlier presented. You can also send it to me. You can send it to me and copy Josiah so that we can keep track of those people that are interested in the very direct molecular practical training. because that is one of those things that we are planning to reach, to get to do this coming year. We're also planning to reach out to students. We're planning to reach out to lecturers, especially those that are into some form of, let me say, scientific researches and may be interested in doing some more in-depth analysis of some of the things that they have already got. They already have the facilities, they have the lab. All they need to do is to upscale or upgrade the lab, and they're using a low cost, at least entry level, using a low cost to commence the activity, and then they can go forward from there. So please, we are still welcoming questions. I know somebody asked, when will this come up? Yeah, so when will the training come up? Robin, I think we are still in discussion about that, but I don't know, Robin, we will also appreciate your input.
Well, I think we will discuss and work something out with Dr. Adebayo. Then we can come back to you. But let me just say, in my own experience of 30 over years in this whole area, I think there are, a tripod. A tripod has three legs. All right. We need to approach things from a more integrated perspective. Government laboratory, government, for example, sometimes they buy things. All right. They buy, then they figure out what to do, how to do. All right. I think our approach has to be like a tripod approach. One of the leg, for example, will be the hardware, the systems. What are the suitable systems? Number two, the platform, how to detect. All right. Do we have the second leg? The third leg will be the competency and the skills. And I think for capacity and capability building, we need to focus on these three areas again and again, rather than just look at the hardware itself will solve all the problem. The hardware doesn't solve a problem. You can have a car, but if you don't know how to drive or maintain the car, it won't get you far. All right. So we need to have a more integrated kind of approach. So I think some of the things that we can maybe next year, Dr. Adebayo can actually put forward would be systems, training packages, and depending on what you want to detect. If it is even in Nigeria, for example, in the aquaculture, if you are in aquaculture, for example, TILV, for example, or some of the viruses or some of the bacteria, or even in the livestock, chicken, usually will be respiratory viruses, the NDV. It can also be avian influenza virus. All right. So all this, we can actually have that detection platform to work with the system, and on top of that, with the skill training to allow the whole setup to operate to function optimally with output and concrete output. I think those are things that we all can be done, and it has been proven it can be done at a very affordable cost.
Yeah.
Yes.
You're right. You're right. So we should be kind of strategic, so that we are not going to eventually ask ourselves, why am I getting this? So let's first know, okay, these are the things that we can do with what we want to get. And these are the way to even go about doing what we want to actually use. And by the time we get to know that and what that can actually achieve, then we can move to the next level. Which one am I getting now? And which one do I have? And all of those questions before we move ahead. But just be sure that we actually have a package for everyone that is interested, and that will be duly communicated to everyone by this coming year, because we are actually adequately planning and preparing for that, so that everybody can actually move from just this training to more physical, practical training, and then to other things that may follow or you may be interested in particular after that has been done. So I don't know if there are other questions. Like I mentioned, you can raise your hand, you can type in the chat box, and then you can actually use question and answer so that we can actually attend to all of the questions that you may have. I have already sent my email address to the chat box, and you can pick it from there in case you want to have a further discussion or so interaction with me. You can actually do that through that email that I've sent to the chat box so that we can keep in touch so that we can take it forward from here. Really, I would like to appreciate everyone that has participated in this training. We're so very grateful. Certificates will be available for those that are able to participate in the training, which will be sent to the individual's email in due time, probably before the end of this coming week. You should be able to have that in your email. And we are also going to be communicating through the email. So I would like to encourage you to look at your email more often, as further communication also will be done through the email about our plan that we are having for you the coming year. I would like to actually appreciate Lab-Ind Resources for this great enlightenment and inspiring facilitation. I would also want to appreciate everyone that has joined us to make this a success. Like I told you, this is the grand finale, and we'll be rounding off for this first aspect of capacity building and training, and we will be able to do more in the nearest future with so many other more physical, practical sessions that will be useful in the diagnostic and the science world that we have. So thank you very much, everyone. Thank you once again, Mr. Robin. We really, really appreciate your wonderful presentation. It's so inciting. Regarding the question around PowerPoint presentation and the recording, yes, you're going to be able to have access to that probably before also the end of next week. We should have been able to package it together and send it to everybody that has participated in this training. Once again, thank you very much, everyone, for your participation. And we want to say, see you very soon. I think that's what